So the word pattern itself is a concept. It means that a pattern is an approach to solving a common problem. It's not a prescriptive set of classes or functions. So patterns as a concept in programming basically sort of came out in, I don't know, the 70s or 80s. I wasn't around, but there's a very popular book called Object Design Patterns, I believe, by the Gang of Four. If you look up design patterns, Gang of Four, you'll find this book from a while back where they basically outline something like 100 different patterns. What a pattern is a way that you could write your code, not the exact syntax, but to solve a common problem. Often, if a pattern will work in many different programming languages. So a few of the ones that we're going to look at are in this are, let's see, we're going to look at the factory pattern, service locator / container. That one's a tricky one. And the decorator pattern. These are patterns that I use all the time. And they just make my job easier. And we'll see what problems they solve. We'll try to define them and see what problems they solve. And we can talk a little bit about why it is a pattern as they come up. So there are definitely more patterns than this, by the way. There's a link at the end of some of these that links to like a really nice PHP pattern sort of documentation library that I'll pull up just to sort of show what people think of are common patterns and good patterns in PHP. So let's start with the factory, because that one's pretty straightforward. A factory is a pattern of creating a new class whose sole purpose is to create complex objects reliably and easily for you. So think about the word in everyday life. A car factory is a thing that just produces cars. That's its job. It just pumps cars out all day long. So we're going to write classes whose job it is just to create instances of other classes. So we're going to go back to pizza for just a moment here. We're going to create a simple factory, or that's the name of this pattern is a simple factory. But we're going to create a factory that makes complicated pizzas for us. And what we're going to do is, this is a class that has one method. That method is create veggie. It could be create veggie specialty pizza or whatever. And this is on our pizza website. We've got a section that is specialty pizzas, and we've got one that's veggie that just comes with all of this already. And that's sort of where the concept here came from for this example factory, is that lots of times people order the same set of things at a restaurant all the time. And there's a shorthand for that. It's like meal number 6 or whatever. So our pizza factory is just going to create a new pizza, add these common toppings to it, and return it. That's all it does. We have now every single time throughout our entire system that we need this complicated pizza, we don't want to write 8 lines of code over and over and over again. We've moved the responsibility, or we've made it easier on ourselves of building this complex object of a veggie specialty pizza off into the responsibility of this other service that is a specialty pizza factory. It's a pretty straightforward concept. And I think if you could imagine how complicated data can get in a real system, like think about the most complicated type of node you've ever created. It might have 100 fields. And like, what if you had to write the code for new node and populate that node object out every single time you needed a node? Nobody wants to do that. Someone made that easier for us that we never even had to think about it. There is a node factory out there somewhere in Drupal land. It's probably called an entity factory. It might be called something else, but it's meeting this pattern, the pattern of being a factory. So a factory isn't always So factory isn't always just sort of like off on its own into its own class. When you make a class whose job it is to hold different factories or make factories available to the rest of the system, that pattern is called the simple factory. But you also have a pattern that's called a method factory. And that's the idea of that this type of object, this data type of cat API consumer can create instances of itself. So generally the way this works is you'll create a static function in on your class. The static function means that you can run this function without an instance of the class being available. It's actually this this function is stored in the memory of the system without an instance of the cat API consumer existed. So that is how we're able to run static functions. That's that's how static functions work. This is already in memory somewhere. So when you add a static function to an existing class and that function's purpose is to create a new instance of itself, that's called a method factory. We have added a factory to our cat API consumer. And now whenever we want a new instance of this cat API consumer, we run cat API consumer : create, and it does the hard work for us. It creates that credentials class, it creates that HTTP client class, and it passes it into a new instance of itself, which is the cat API consumer. And so we get back a fully built, um, ready service, cat API consumer service, because this factory made it easy for us. This is really, this is very useful in the next section when we talk about service locators and the container. Just remember that a method factory is a static function on a class. It's on a class that creates a new instance of itself. Often that function is called create. I think even in the early days of Drupal 8, they even had like node : create or node : load. It they they used to a while back, you used to be able to load nodes using a method factory that were on the node class, and now I think we go through the entity type manager to load nodes. All right. And that's the whole idea of a factory. It's a thing that creates complex objects for you so that you don't have to write that code over and over again. If you are creating new classes, new data objects, new models for your system, consider creating a factory for that object. This should be a comma, because that's going to make the rest of your system more easily make use of your new types of data. Here is that link that I was talking about. Let's look at the simple factory. So here on this website, Design Patterns PHP, you can see like a big list of all the different not factories, but patterns. And they're even broken into a number of sort of super types. You've got a type this type of pattern is for creating things. There's a lot of patterns out there, and these are the ones that whoever runs this site, thought were important enough to document on the site. It's a useful reference, this Design Patterns site. Any questions about a factory before we move on to the service locator pattern? All right. We can always come back. So let's just take a look at the service locator. So the purpose of this pattern is to make reusable classes, to make classes available easily throughout the rest of the system. So what this class is, a service locator, in this rough sketch of a service locator that I created, is a class that holds a bunch of services, or doer objects, or verbers, if you will, or services. I'll stick to that, in an array where they are keyed by some name, whatever name you give them, and the value of that service, of that item in the array, is an instance of that class. So then some other part of the system can use this service locator object to get one of those services by its name. So Here is an example at the bottom where we have created a new instance of the service locator class, and we're going to add a service to it called the cat API, which is just a new instance of, a new theoretical instance of our API consumer. And we're going to add the specialty pizza factory to it. And so later on in our system, somewhere else, much deeper, much further away in a contributed module or in the theme or something, this service locator exists and it's still available throughout the entire system. And something else, some other part of the system can go to the service locator and say, give me that cat API so that I don't have to make a new one myself. Because remember, ideally services are immutable. Since in an ideal world, the behavior of a service never changes, then it shouldn't matter where I get it or when I get it during the running or during the system or during the execution of the page load or somewhere throughout the system. It should never matter, because every single time I am using a service, I expect the same results, because that's how we decided to design services earlier. So the service locator pattern is one that lets us get named existing services. And the reason that we want to get named existing services is that they always work the same way every time we use them, because we designed them that way. And therefore, I don't need to keep creating new instances of the cat API consumer all the time. I should be able to go get the one that was used in this totally other module part of the system and run its methods in my context, and everything should work out fine, because it always works the same everywhere, because we made a good service. So that's the point of a service locator. It stores instances of classes. It stores objects, ideally service objects who work the same everywhere, so that other parts of the system can easily retrieve that existing instance without creating a new one. So Drupal has a service locator. There is a class in Drupal called Drupal, and it has a static function on it called service that you can pass an ID in, or the service name, if you will. And what it does is it goes and gets this other thing it calls a container, and then just runs that container's get method, passing your ID right along. So if you've ever seen this type of code in a code base, in a custom module or contrib, or Drupal core has this written all over the place, this is making use of the Drupal service locator. The idea of that you're going to use Drupal :service to just go get some random class, or in these other cases, the Drupal config method actually calls the container and runs and gets the config object from the container. These three are just shorthand for the fourth one. They're all making use of the service locator. If this doesn't look familiar to you yet, get ready, because you will see it in Drupal. And we're going to come back to why this thing is called a container very shortly. So the problem with the service locator, see, I'm gonna mix it up here. A service locator is considered an anti-pattern. It's a bad pattern. The problem with a service locator is that it couples your code to the service locator object. So let's look at our cat API consumer. If when we were instantiating our cat API consumer, we went and reached out to the Drupal service locator to get the existing HTTP client service, then what we've done is we've created a dependency of our API, of our custom class, on not even this HTTP client, but the service locator itself. This code could never run with outside of the context of a fully functioning bootstrapped Drupal website. Even if the HTTP client service that I want has nothing to do with Drupal, if it's a Guzzle, an instance of a Guzzle client, too bad, because I have coupled my code not to that client, but to the service locator. So using the service locator directly like this accessing, requesting services from the locator directly in your code is is an is using the service locator as an anti-pattern in a bad way, because we've actually created a dependency on our cat API consumer that is the service locator itself. A good thing we can actually do something about this. So let's go back to, our dependency best practices. We're not actually going to use our service locator in our classes ever, because that breaks our rule of dependency best practices. And instead, what we're going to do is we're going to, get the value of the service locator, get what we want out of the service locator, and pass it into the new instance of our class. So we're following our dependency best practice rules, meaning that there are no dependencies inside of our classes. We're going to pass everything in. And therefore, now our class is no longer coupled to the service locator. It doesn't care about the service locator. It doesn't at all. It's no longer a dependency of our class. And so what we've done is we've not avoided using the service locator. Note this, we've changed how we use it. And really it's not a difficult change because we've already learned about dependency best practices. But changing how we use the service locator makes a difference. So rather than having the service locator in our class, making the dependency, instead, let's make a simple factory for our cat API consumer. We can pass the service locator into that class, and so into our public factory, our method factory, because since the factory is just attached to the class itself, we didn't create any dependency on this service locator. And I know it looks a little odd here because the word has already become container, but we'll see how all this glues together on the next slide. So we can make use of our service locator in our code for our custom class, but by moving it to a factory, we've still allowed the instantiation of this class without the service locator. So this factory helps us create the class, and it's great. It's cool if it uses the service locator to get the HTTP client, because this factory is not a part of the fundamental functionality of the class itself. I can still create a new instance of the cat API consumer without the service locator. So I've not coupled my class to the service locator by simply adding a method factory to my class. That's a little bit of a leap. So let me go to the next slide, and then let's do questions on this, because I'm hoping to glue this together, because it's going to make a pretty big splash in the way you might write some Drupal code. Okay, so here's the point. If we change the way we use the service locator, and we don't make use of it inside of our class as in a way that couples our class to the service locator itself, then it's no longer an anti-pattern, and it's no longer even called the service locator pattern. Instead, we are using the service locator as just some way of getting the dependencies of our classes, and then we're passing those dependencies in our classes, leaving our class decoupled from, or not coupled to, the service locator at all, because our class only cares about the exact dependencies we need. By changing the way we use the service locator, it's no longer a service locator. It's now a dependency injection container, and that's where the word container came from. So it's a little weird to wrap your head around, or it might be, I don't know, maybe it's not. Maybe this is, old hat for y'all. But the code for the service locator didn't change at all. It's still a class that holds an array of named instances of other objects. In how we used it, it changed from one pattern to another. All right, so we didn't change how the service locator works. All we did was change how we used it. I said that a lot without going to this slide. So the best practice is that we don't use the service locator directly in our custom classes. We don't do this because we are coupling our classes to the wrong thing. We are creating a dependency connection between our custom class and the service locator, which is actually not something we care about. We don't ever care about the service locator. Instead, we're going to use the dependency injection container to to get services that may already exist and pass those services into our class like normal dependencies in the constructor in a good way. Additionally, we can simplify this by adding a method factory to our classes that creates a new copy of this for us. That method class can totally accept the entire container. And the reason that the method class can take the container and you and therefore creating this class itself or this method itself is it is coupled to the container. But the reason that's okay is because this functionality is not important to the everyday use of the CAT API consumer. This functionality is just a factory. It's just here to make the creation of CAT API consumers easier. All right. Here's a summary page. Let's see if this makes sense. I feel like I've already hit all these numbers. Does anybody have any questions about the service locator pattern or the dependency injection container? The next thing we're going to look at is how to do this in Drupal. All right. So services dependency injection in Drupal. So in Drupal, when you're writing a custom module and you want to define your own custom services, meaning that they are available as a named thing in the service locator, you'll write this into your modules YAML file. So your modules .services.YAML file. And when you define a service, you give it its name. In this example, it's my service name. And that is the name of your custom class or the instance of your custom class in the service locator, so that when other parts of the system want to make use of this example class, they would request it from the service locator by the name of my service name. And the nice thing about a really sort of fleshed out system, a dependency injection container system, like the way Symfony provides, is that it's smart enough to compile itself, and you can pass into the services that you're defining other services as the dependencies of your service, and not just services, but other values. So for example, my custom service here expects or demands 2 parameters in its constructor, otherwise it can't exist. It's expecting the entity type manager and some other service. And so when I'm defining my service in the Drupal 8 YAML file, or my modules YAML file, excuse me, when I'm defining my service in my modules YAML file, I have the option to provide it, quote, arguments. And this is just a YAML array that accepts different YAML data types. And specifically in this case, if you pass in as arguments strings that start with the @ symbol, that signifies for the container that when it's building, that what this argument is another service named entity type manager. So when we're defining our services, in another way of putting it is, when we're defining our services in the YAML file, we can easily define the dependencies of our service as arguments here in this definition. Then what happens when the container is being compiled and something requests our service from the very first time from the dependency injection container? It says, give me that service named my service name. Then the service container is smart enough to look at the arguments and say, like, okay, I got to construct this thing because this is the first time it's ever being instantiated. And oh, two of these arguments are other services with these names. So let me go get the entity type manager service and pass it into the constructor as the first parameter. So in a fully fleshed out dependency injection container system that Symfony provides, the dependency injection container is smart enough to uh, to build your service based on these arguments. It's really useful. Otherwise, we'd have to find some other mechanism of registering our service with the container. What happens when the container is being built, it it detects all of these dependencies and ensures that they exist before that container object is fully built. And in doing so, it detects the order that things need to exist. And that's why you can accidentally end up creating like a circular reference. Like if some other service demanded my service name, I've made this complicated by putting the word service in every example here, but if this service required a dependency that was this service, then we'd have a circular reference, and neither of those could ever really be instantiated because neither could be fully built. And when you're writing that out in your custom module and you run drush cr to clear the caches, then the container will fatally fail during that cache rebuild because it couldn't possibly ever provide one of those for you. Also worth noting here is that the arguments that you pass into your service, they don't have to be other services. If they are other services, it's a string that starts with an at, but we could pass in numbers or normal strings here if we want, or objects or arrays. It's basically going to say that whatever the first argument is, whatever it is, pass it in as the first parameter of this services constructor, the second argument, the second parameter, and so forth and so on. So that's great. That is how we define, this is roughly how we define services in Drupal, and also how we define the services dependencies to be automatically injected into our services by the dependency injection container. In this example, in this scenario, in Drupal where we work, the container's doing a lot of work for us, and it's really great. Oh, I guess that was the end of the last session. I probably should have gone to that slide and then taken a break section. So that is the services dependency injection in Drupal. And I have many more examples of services and dependencies injection coming up when we get to the all about Drupal section. But we're still in patterns. And so we've got one more pattern to look at that's really useful, and that's the decorator pattern. So let's take a look at the decorator pattern. So the idea of the decorator pattern is to extend the functionality of a class through composition. So let's take, for example, a scenario in which we have a product of some type. Maybe it's a pizza. I didn't extend that metaphor, but we could. So let's say we have a product that's a pizza, and we need to be able to provide it with its taxed price. We need to provide the system with the taxed price of this pizza. Well, taxes are different everywhere. And so it's not really the pizza's responsibility to know about the taxes for every state and every country and every planet. It would be better if this was done by another thing. So in this contrived example, I've created a new class called a taxed price. And what it does is it accepts into its constructor any product, which just to reiterate, in the real world, I would have type hinted this with something probably like product interface. And it stores a copy, or it stores that thing on itself. Generally, it stores that thing on itself. And then it provides a new method for calculating the tax price of this thing, this product, as a function or as a method on our new class. So this idea here of extending functionality through composition, like simple functionality, is the decorator pattern. We have decorated, you could say, this product class, this product object, with a new piece of functionality that calculates prices for us, tax prices for us. So really what this is great at is it allows us to separate the concerns of the object, and especially across like business domains. So in the case of our cat, let's consider that we have this cat object and it's got a bunch of properties. It's a data object. It holds a lot of attributes, and like it's got its type. It's probably got hair color. It's probably, got number of claws or something. All of the different attributes that a cat may or may not have are available on this class object. But what we want to do is we want to easily be able to get a picture of this type of cat from our cat API service. So we could do that by accessing the service and then like using that service to make API calls for every little cat. Or we can create a new class that is a cat picture decorator. We can decorate this cat with a new class whose job it is to access the cat API service for us for this given cat's type. So we'll do that by making a new class. And in the construction of that class, we'll expect a cat instance. I really should have put the type hinting in where it would have fit. I just sort of let that fall by the wayside. But yes, all of this would be type hinted. To be able to decorate this, to be able to write this decorator, we expect the thing it's decorating, the subject, or the sometimes called the inner object of the decorator, and we'll save that. And we'll also take the service that we're going to use to do multiple things, to make multiple requests about this type of cat. And now we've got our cat API service here as a part of this decorator. And now every time we're dealing with a system where we already have the cat instantiated, and we want to extend the functionality of that existing cat instance, we will decorate it with our new class, and now our cat can get its picture through this decorator. So let's see what this next slide looks at. So I want to reinforce this a little bit. So we could have made our cat class capable of fetching an API, a picture from an API, but is that its job? That's an awful lot like doing a thing, whereas our cat really is just a series of attributes. I mean, the things it does, it should only do to itself, whereas reaching out to an API and all the different complicated parts that deal with that that behavior, I would argue, are not the responsibility of this cat data model. The cat should know about itself. Maybe it can sleep in the sun, but otherwise it can't go fetch cat pictures online. So we've extended the functionality across a business domain by using this decorator pattern. So let's think about this a little more, and let's tie it into Drupal. Let's say that we've got a content type called cat, and it's got a bunch of fields on it. It's got a bunch of data about it. It's, everything you could think of about data around a cat type. And since it's in Drupal and we're dealing with a node, it's already got multiple levels of inheritance built in. It probably has like 4 or 5 ancestors and whatnot. And the node instance generally already exists where we want to make use of it. Consider that we are hooking into node view and we just want to add the cat picture to the node view. So the entity is fully built. So how should we extend the functionality of this entity in such a way to where we can easily get our picture without, the easiest way to get our cat picture or other cat data that's not necessarily
that's not a part of the entity itself. So what if we did it through inheritance? In extending node, we would be getting its constructor. We could override it, but we'd still have to fulfill that node's constructor when instantiating a cat. And we could, in our get picture, we could go out and get the service, or we could do that in the constructor. And now we're coupling our cat class to the service locator. And maybe you could find another way to do it, but you're still making it complicated. And then let's get back to our example about where we're into the hook node view, this little thing. And so we're back in hook node view, and we've gone with this inheritance approach, and the entity comes into hook node view and it's already built. So what are we going to do? How are we going to run get cat picture? Well, we're going to have to reinstantiate this node, but instead of as a node, it's going to have to be reinstantiated as a cat. This has a number of problems with it. So first of all, we have to reinstantiate it, which means we gotta pass in all its values and entity type and bundle and translations. But also, this is an event that's happening at some point during runtime. This entity that's coming in, this node that's coming into hook node view, may have already been modified. It may have been its job as something that holds state as a data object may have already changed. And so we can't just, or we don't want to just do another node load or a cat load and load it fresh from the database, because what we really need to deal with is this instance of the entity, the one that may have been modified. So what we'd have to do is we'd have to use this instance to construct a new cat. And that is a whole lot of work just to tightly couple our class to the service locator. And sure, we could probably pass it into the constructor and avoid that coupling. But long story short, this is a huge hassle. It's not convenient and it's not efficient. So instead, this is where the decorator pattern really shines. Instead, we want some data out of this node and we want to extend it in a reasonable way. And so we're going to do it by, I keep selecting stuff, by decorating the existing entity in its existing state with its existing values with our new cat picture decorator class. And now here we are in hook node view, and we're like, oh, that entity, that's great. I don't care what its values are. I'm just going to wrap it in this really simple class that extends its functionality in just the ways I need, very simply. And now I can go get cat pictures of this cat type, or I could go do other cat related data tasks that are not the responsibility of the node itself. So I hope this example highlights like the value of the decorator pattern. Like there are certainly other ways to achieve this exact solution with the hook node view example, but I hoped that this would be like a very Drupal-y sort of practical approach to it. Now, something else I want to highlight is that the decorator pattern that I'm showing here is for decorating data objects. In the case where you're decorating service objects, there are some other considerations that I hope we have time to get into, but I don't have a series of slides for. I do have examples that we can look at in code, and it seems like we're going to have time to, but just know that this decorator pattern I'm showing is for decorating data objects, and the value we're getting out of it is we're separating the concerns, the functionality of that data object. We're extending the functionality of that existing object in its current state is important, that I should have written down. And we're doing this without reloading it. We're doing it very efficiently.
And here's a link to the decorator pattern from that website that we looked at earlier. Does anybody have any questions about the decorator pattern? This data object decorator pattern. All right. And if you do later, that's fine. We can come back. So I do have this little slide about service decorators, which are just a little different. And we can get into this in a later part of the training where we can look at code a little more in depth. But I was already 100 something slides deep, and I just didn't have time to throw this in here. But heads up, when you're defining services in Symfony, they also provide mechanisms for decorating other services. And it means the same thing. It means that we are going to create one service class that wraps another service class in order to change its behavior or extend its functionality. But the actual implementation of it is a little tricky, because when we do that, we have to provide all the original functionality of the thing we wrapped on as a part of our decorator. So here's what happens from the Drupal services or the Symfony service decorator perspective. We've got this simple service up here that is a password generator. And this is available in my examples GitHub repo that we can look at as well. So we have a simple password generator. It just generates some random strings and numbers together. And there's not much to it, but we want to extend that functionality with another service. So we're going to make another service that is a class that decorates this original service. Now, the result of what happens here is that when some other parts of the system request this service from the container, well, Symfony actually returns this service. So this service has replaced this service, sort of. This service, what happens, okay, here's what actually happens. Symfony loads this service. It finds this first one. It finds everything that's registered to decorate that service. And then it performs that action of instantiating a new copy of this by passing the first one into it. So what you get back from requesting this original service is actually the decoration, this second service. And many services can decorate each other. So, but the reason that I want to point out that this is a little different than the example I showed before and a little trickier is that if something is requesting this service, this main service, the primary one, let's call it, sure, the subject, then it's expecting all the functionality of that subject. Like it might have a dozen methods on it, and the part of the systems that's requesting this service, it doesn't know necessarily and doesn't need to know. It shouldn't need to know that this service is decorated. So what we end up having to do with our decorator service is we have to make sure that every bit of functionality that is available on the thing it's decorating is available on our decorator. Otherwise, it's you're going to surprise a lot of parts of the system. So it's a little, basically just a heads up when you think, if you mainly know about decorators, or you've worked with a lot of decorators in Symfony before, and you've dealt with sort of the challenges of this aspect of it, where you have to make sure your decorator provides all the functionality of the thing it's decorating, then it's a little different than the example I showed before. That is all. Any questions about the decorator pattern? And we can get more into service decorators later. I think the easiest way to sort of start with the understanding of the decorator pattern is this idea here, where it's a simple extension of a data object. Um, and it doesn't care about the data's state necessarily. We don't have to reinstantiate that data object um, at all. It just simply extends a little ad hoc, I guess. So there's a question. Let's see. So if there's an update to the main service in core, the decorator code is fried. Well, yeah. So if if we made a decorator service that extended a core service, and then that core service did, like change its method signatures or something like that, yeah, it would be um, it would be a problem. If it added new methods, then there's sort of ways around this. I would There are ways around making your service decorator adaptable to minor changes of the thing it's decorating. But ideally, like if you're decorating something from core, then you're also paying attention to if core starts deprecating methods or even the entire service. That's probably something that you only really need to worry about in a major release. So upgrading from like Drupal 8 to 9 or 9 to 10, you're gonna you're gonna have a lot of work to do there. And this is just one of the places where you're gonna need to need to check in. Like, did the things that I decorate change significantly? Does my decorator now break that original service that it was decorating? But thankfully, Drupal's version control, sort of like keeping up, I can't even think of the word right now. The way that they are careful about versioning and deprecating code, and they only remove it much later, is is really well defined, and we know when it's going to happen. So, how do you keep track of the custom decorators is a good question. Ideally, you don't need to. The In the case of a service decorator, ideally you don't need to, because no matter what you get back from requesting this service, it it has the functionality you expect. The decor Like are some of the decorators that are applied to this service may change that behavior, but the behavior exists. And there's a good bit more to this. You can change the order in which decorators are wrap the original service. So you could have one decorator happen very early and another happen very late. Generally, it shouldn't matter. If some part of the system is decorating a service, then that functionality is desired by the system. If you installed a contrib module that decorated a service and just made it act really weird, I would pick a different contrib module. Or there's always the option of redefining this service under a different name. So I could always copy and paste this code right here, give it a different name, and now I could get that new copy of this service that nothing is decorated. Even core services, you could re-implement core services under different names if you want. It's as simple as copy and pasting some code from core.services YAML into your own module. But hopefully you don't have to do that. If you have to do that, then someone else made a bad design decision.